For our bell work today, we do see some parentheses there, so we are expecting some distribution. Just be careful because this is distributing actually a -6, not +6. So that's, I'm gonna make that 1x, but that'd be -6 times 1x's, which would be -6x's. And then also we have -6 times -1, which is +6. So everything else stays the same. 6x equals the 6 minus 6x plus 6. Now I would look to combine any like terms, which I have as constants. 6 plus 6, which is 12, positive 12. Then I can drop my -6x and my 6x in black on the left. So now that we've combined any like terms, we're looking for principles of equality to isolate the x's. We do have x's on both sides, and so I will show that I want the x's on the left and the numbers on the right. So scanning this, we got 6x, which is on the correct side. 12 is on the correct side as well, because I crossed over the line, so it's on the number side of things. That's good. But the -6x is on the wrong side, so I'm gonna have to zero that out by adding 6x to both sides. Okay, so on the left, 6x plus 6x's would be 12x's, and then this will equal, we'll just drop this 12 constant, and -6x plus 6x, that zeroes out just as we had planned to happen. So last thing here is we want this to be 1x, and to make a 12 a 1, we just simply divide it by itself. But if I do it to one side, I need to do it to the other side also. So that does give me 1x, and then on the right side, 12 divided by 12 is also 1. Now I'm gonna go back up to the top, and I will replace both x's with this 1, and that will be how I check for truthfulness. So on the left side, 6 times 1 is 6. On the right side, 6 minus 6 parentheses, 1 minus 1 is also 6. So that's going to be a true statement. And since it is true, I can now box that in with confidence, knowing that I have found the solution. So that's a nice review of stuff that we've done already, and we did see x's on both sides with some distribution and combining like terms. It's a good review. I can use distribution and combining like terms to solve equations, and I can use principles of equality to create zeros and ones and solve equations. And also I can write and solve equations that include area and perimeter of shapes. Okay, take a minute to copy these down, then we'll get started. Again, these first two ones aren't new. This third one really isn't new either, because you have seen perimeter of shapes, but today's lesson is more of a review of that kind of stuff that you've seen. So the perimeter of a shape is the distance around an object, which it's kind of like how much fence you would need to close in a field or some kind of shape. Okay, because it goes all the way around the very edge of the shape. And so really all you got to do is figure out the length of each side and then add them all up and you get the perimeter. Although today I think they're going to give us a perimeter, and then we may have to find the length of a missing side, which an equation may help, but not everyone uses equations, and I don't think you'll be forced to use equations either, but you can. So for a problem like this one, all right, so I got this, I don't know, I'd call this a star shape, and it's got 1, 2, 3, 4, 5, 6, 7, 8 sides to it. So it says find the perimeter, which means all we're going to do is add all the perimeters together. Okay, so I'm gonna start here, and then I'm gonna go, well, actually, you know what I'm gonna do is I'm gonna start there. It's 9.9. Usually what I would do is I would go around the shape, just add all the sides together. But on this one, I noticed that there's lots of side lengths that match. So what I would like here is to take my 9.9 and just multiply it by however many of those there are. So there's 1, 2, 3, 4, 5, 6. So I counted 6 of those 9.9s. So if I multiply 9.9 by 6, it would be the same as adding all 6 of those side lengths together. But then I got 7.3, which also repeats. So I'm going to take that 7.3 and multiply it by however many there are. And I counted 2. So I got 7.3 times 2. And again, that would be the result from those 2 side lengths. If I wanted the full perimeter, I would just add these 2 together, and then that would give me the perimeter. So sometimes they'll show it like this, P equals that stuff. You don't necessarily have to, but I'm putting the P there so we know that we are actually solving for the perimeter. But now that I have that, I'm going to take all this stuff, And instead of doing it part by part or term by term, I'm going to just put it all in the calculator. 9.9 times 6 plus 7.3 times 2, enter. And the calculator tells me that would be 74. And then these are lengths, so we want to actually find the unit of measurement that they're using, and this one, it says it's in meters. So adding all those together gave me 74 meters. There we go. So here we go. We get the perimeter of this figure below is 144.5 feet. Find the length of the missing side. Again, they've given us the perimeter, which means if you added all these side lengths together, you get 144.5. Now the problem here is that one of the side lengths is missing, right here, the question mark. So I'm gonna pretty much kind of set up this the same way that last one did, because I've got some repeating sides, right? So I got 13.5 3 times. So for my perimeter, I got 13.5 3 times. So I'm just gonna multiply that by 3. And then another side that repeats, I got 14.1. That happens twice. So from there, I'd have to add 14.1, but multiplied by 2. And then we have the single side lengths, the 22.1, so I'd have to add that in as well. And also the 44.2. So that's not actually the full equation, as it turns out. What we need now is also to add the question mark, okay, because that represents the missing side length. So this would be adding all, what is that, 1, 2, 3, 4, 5, 6, 7, 8 side lengths together. But this would equal the perimeter, which they gave us up here at the top, 144.5 feet. So for my perimeter, I have 144.5 feet. And now I'm ready to solve this equation, right? So I'd say you could combine like terms, but we got some multiplication to do with the parentheses, right? With parentheses, we do expect some distribution. But in fact, I can actually just type this all into the calculator. But after adding all those together, in the calculator, I get 135. So this means that if I were to add that to the missing side length, it would equal the full perimeter of 144.5 feet. So this becomes a one-step equation that we need to solve at this point. And it's not too bad, because we can just take this and zero out the 135. Now you notice that I'm using the question mark as the variable here. That's okay. But if I subtract 135 from one side, I gotta do the other side. So 144.5 minus 135, enter, and I get 9.5. And yeah, that zeroed out the 135, so I can just drop the question mark. The question mark was the missing side. The last thing I really need to do here is just label that in feet. And that would be the length of that missing side length right here. Now you could check. You could go back and add these together plus the 9.5 and see what you get, but you would get that 144.5. So area, how much surface space is taken up by a shape? So if you think about this in terms of a field like we did with the fence, it's how much grass you would need to cover the surface of that field. All right, so again, if you look at any shape, like a rectangle like this one, the red line here is the perimeter, but the inside here, the white space right here, would be the area. So we're gonna need some formulas for the area. So we got triangles, half times base times height. So B is for base, H is for height. And sometimes they'll just say L times W. L is length, W is width. But down here for the rhombus, a rhombus is a four-sided shape where all four side lengths are exactly the same. You need to find the diagonals of the shape. So over here for this one, D is for diagonal. All right, and by diagonal, here's kind of what I mean by that, is let's pretend like I can draw really good. So we'll pretend like this is a rhombus. So this red line here would be a diagonal, and then this purple line would be a diagonal there. Those are the diagonals, okay? Now, a trapezoid is a four-sided shape that has two sides that are parallel to each other. The B's are the parallel sides. And then H is, just like we see with the triangle, H is height. So the B's are the bases, which are the parallel sides. Okay, then H is the height. All right, now for these, because these shapes are kind of new to us, even the triangle like this, when they want to show height of these shapes, whether it's the triangle or even the parallelogram or trapezoid, the height is usually indicated or shown. It's usually shown with a dotted line. In addition to that, the dotted line has to be 90 degrees. With whatever the other side is. Usually it's length. Okay, so here's what I mean by that. Is if we were to see, let's say we saw a triangle like this one. All right, and sometimes the dotted line will be red, so I know this isn't great because I'm doing it by hand. So they'll show the dotted line like that. That line would be the height. Now, in addition to that, they'll show the 90-degree angle with just the box. And the box right there, the 90 degrees, corresponds with this line right here. So this line specifically would be considered a base. Okay, now again, if this was a trapezoid, they'll still have, you'll just have two bases. This line will create a 90-degree angle with two different lines. Okay, but it's important to understand these so that we can plug these into these formulas. So here we go. We got this is a right triangle. So for some of you guys that remember this stuff, that's kind of like Pythagorean theorem stuff, but we're just asking for the area of this one in square meters. And we'll need to remember that because we got to label our answer. Express your answer as a fraction in simplest form. So we do want the fraction here. But what I notice is that it is showing the 90-degree angle there, right here. So for me, I would say that this is the height. Now some people would say that's not the height, that's the base. It doesn't matter because of the commutative property of multiplication. But for me, I would say that that is the height at 4/3. Now I am operating with fractions, so I will even put that in parentheses. And then the other length right here, the 5/3, see how it creates a 90-degree angle with the height? And again, that 90-degree angle right here. And so I would say this is the base. So my base then is 5/3. And again, I'm just putting that in parentheses, and then I'll have to multiply that one by 1/2. In the calculator, I'll put this in parentheses as well, just because I'm operating with fractions. There we go. Okay, so I go to my calculator. In parentheses 1/2, close parentheses, new parentheses, 5/3, close parentheses, new parentheses, 4/3, close parentheses, and I push enter. Now my calculator says that the area of this, okay, so my calculator, it give me this answer 1.1 repeating, and yeah, that'd be the area of the triangle. But it said it wanted the fraction, so I'm just gonna push math, enter, enter. So math, enter, enter, and it changes that into a fraction for me as 10/9. So 10/9 will work, okay, and that's the area of that triangle. Okay, but again, it did want the fraction in simplest form, and just so you know, this calculator will always make your fractions in simplest form. So this is the one that we want. Of course, we should label that though, right? So let's give ourselves some space and then label that. Again, it said it was in square meters, so that's the meters to the power of 2. That's what we're looking for there. So it may require us to solve some equations, so yeah, we're looking for solutions, which is just values you can replace variables with, whether it's h, l, w, or b. Doesn't matter, we just need to be able to replace those values with numbers to make them true. So principles of equality, of course, we do this with purpose, right? So addition and subtraction principles of equality, we use these two to make zeros, and that is to help us isolate variables, which we've seen. We've seen these been used on x terms as well. And then we use multiplication or division to make ones. Usually it's the division principle of equality that we make ones with, because we're looking at doing that with the coefficient. So we saw examples of this on the Bell work, but we'll see more examples here on some of these classworks. And yeah, the process for solving equations, we know we use distribution, which is multiplication. If we see parentheses, we use distribution. And then after that, we combine the like terms, if there are any. And then we use principles of equality, whether it's addition or subtraction. We use those to make zeros. That's isolating the variable. And yeah, like I said, we may have to zero out x terms if they're on the wrong side of the equal sign. And then the last thing we do is make the coefficient of x a positive one. Usually it's the division principle of equality, but we may have to use multiplication, which we did see on the mastery quiz. So this one, the area of the triangle is 3.63 square inches. What is the length of the base? And so they're showing right here, this is the height. How do we know it's the height? Because they've shown this dashed line right here, even with the 90-degree angle. So this line right here is the base, which I don't know. So I'm just going to use b for base, and I go to the equation. I know that the area is 3.63 square inches. So I take the area and I replace it with 3.63. And then this would equal the 1/2. We don't know the base value, so I can't really replace b with a value yet, but we will solve for that. And then the height was given to us as 2.2. So in solving this equation, you could even say there's distribution at this point, but really all I'm doing is multiplying the 1/2 times 2.2, which would be 1.1. So now 3.63 equals 1.1, and then notice we didn't do anything with the b yet other than multiply the other two factors. So 6.63 equals 1.1b, and then last of all here, to solve for b, we just want this to be 1b. Right, so how do you make a 1.1 a 1? Just divide it by itself. But yeah, if you do it to one side, make sure you do it the other side as well. Okay, so that's 1b. In my calculator, I got 3.63 divided by 1.1. Enter, and the calculator gives me 3.3. Now this is the length, right? So I'm just going to label this one in inches, and that would be the base value here. For this one, it says GI is 10.7. GI is the length that is given here. It's kind of a poor line, but that's 10.7. And then it gives us HJ, which would be this length right here. Now, why is this important? Because they told us this is a rhombus, and we need those diagonal lengths in order to fill in the area formula for a rhombus. So I'll just say that D1, the diagonal one, is the value I have in red there, the GI length, which is 10.7. And then the second diagonal would be the purple one, HJ, which it said was 21.4. Okay, so this is a direct calculation on this one. We're just going to take 1/2 and multiply it by the first diagonal, multiply it by the second diagonal, and that will be the area of the rhombus. So I just go into my calculator. Of course, I'll put the 1/2 in parentheses here. It did say it around to the nearest tenth if it's necessary. Let's find out. So 1/2 times 10.7 times 21.4. Enter, and I get 114.49. cancel this. 114.49, but it did say it around to the nearest tenth. So the 9 in the hundredths place value is going to add 1 to the tenths place value, making this 114.5. So the last thing I need to do is label this. These were all in inches. This is an area, so I have now square inches. So here we got a trapezoid. Now the first value that I would notice is the dashed line, which is 18. That's going to be my height. So I go to my formula. I say my height is going to be 18. And remember, for height, it will always create 90-degree angles with the bases. So that tells me that VU is one of the bases, and then WX is the other base. So I can see that I'll say VU is my first base, and that's showing as 20 inches. So my first base is 20 inches. And it, by the way, yeah, it wouldn't matter if you said base 2 is 20 inches. That doesn't matter. But the other base for me is 12. So I replace base 2 with 12. Then I just look at the rest of the formula. Okay, so it looks like this. This will give me the area of the trapezoid. But again, I can put this all into my calculators. Okay, so I'm even going to put the 1/2 in parentheses. And instead to round to the nearest tenth. So we may need the decimal here. 1/2 times 20 plus 12, close parentheses, times 18, enter. And it gives me a straight value of 288. So there was no need to round this one, but I do need to label it. This is an area, so it will be the square inches. Now we got a parallelogram. Again, this one's just base times height, and we can see they've given us the height. It's this dashed line right there, and it shows the 90-degree angle as well. So for me, that's my height, which it shows as 32.4. And then the base is the side length that creates a 90-degree angle width, which is this one. And that shows at 24. So the base would be 24 inches. I want the area, so simply I will just multiply these two, and that will give me the area. So in my calculator, 24 times 32.4, enter, and I get, said to round to the nearest tenth, but looks like it's just 777.6. Again, this is an area, and these lengths were in inches, so I will make it square inches. That's the area. So there's our 3 objectives. I hope you guys feel comfortable doing these.